Hello, welcome to the Cyber Notes Cast, our podcast by the cybersecurity company Cybersecurity, and this content channel is dedicated to presenting the best articles taken from our blog. And today we're going to talk about the 3 aspects affecting cybersecurity in Industry 4.0. Was our content relevant to you? Then share it with someone also interested in the topic. Like other industrial revolutions, Industry 4.0 came to transform the way of working with the digitalization of manufacturing environments. However, this feature poses several challenges in terms of cybersecurity. This is because increasingly sophisticated tools allow malicious users to gain unauthorized access to systems and devices used in the industry, and can promote cyberattacks with disastrous consequences. Therefore, we prepared a Cyber Notes Cast episode in which we explain the main aspects that impact cybersecurity of Industry 4.0. We also covered what needs to be done to ensure cybersecurity in this scenario. To facilitate your understanding, we divided our text into topics. They are: what is Industry 4.0? Importance and benefits of Industry 4.0. Technologies commonly used in Industry 4.0. The 3 aspects affecting cybersecurity in Industry 4.0. Other cybersecurity challenges for Industry 4.0. Measures that provide cybersecurity to Industry 4.0. History of the industry. About Cybersecurity. Conclusion. Enjoy the listen. What is Industry 4.0? Industry 4.0, or the Fourth Industrial Revolution, emerged a few decades ago, focusing on advanced digital technologies such as robotics, the Internet of Things, cloud computing, and artificial intelligence. This concept makes it possible to connect physical and digital environments, allowing joint action between different departments. With Industry 4.0, it is also possible to have control of all operations within an organization, as well as to optimize processes and increase productivity. It can be said that the Fourth Industrial Revolution is transforming business models and production steps with the use of technological solutions. Importance and benefits of Industry 4.0. Industry 4.0 is advantageous for organizations, since it provides more efficiency to processes, increasing productivity while reducing the number of resources required. Moreover, the solutions adopted through the Fourth Industrial Revolution bring other benefits, which will also be detailed below. Reduced operating costs and increased profit. Automation allows one to avoid human failures and delays, reducing losses, increasing the effectiveness of processes, and, consequently, increasing business profitability. In practice, Industry 4.0 makes it possible to improve the use of assets, reduce the costs of their cycle, and produce without interruptions. Customer satisfaction. The advantages of the productivity guaranteed by Industry 4.0 are not limited to the industrial environment, they also involve the satisfaction of the customer's expectation, who also wants to increase their performance. Asset monitoring. Maintaining industrial assets takes time and requires financial resources. In addition, while the equipment is in repair, production remains interrupted and the industry ceases to profit. On the other hand, investing in the Internet of Things makes it possible to detect failures before they generate more costly problems. Thus, it is possible to affirm that asset monitoring and maintenance are one of the great advantages of Industry 4.0. It improves working conditions. Industry 4.0 addresses human needs, allowing to improve working conditions for employees of organizations. This is possible to the extent that it provides data on temperature, humidity, radiation, presence of gases, and accident risks to operators and maintenance personnel. Customized services. Digital tools have brought significant changes in consumer behavior, which today is increasingly demanding and interested in personalized products and services. Therefore, companies that do not want to lose space to the competition need to follow this transformation, which includes the desire for customized items and the possibility of interacting with the brand and influencing its manufacture. For this reason, many organizations invest in digital platforms that allow them to customize products according to customer preferences and shorten the path between production and delivery. For this type of business to achieve its goals and gain a competitive advantage, it is necessary to adopt solutions related to the Fourth Industrial Revolution. More agility. The manufacturing industry requires the agility, flexibility, and scalability provided by Industry 4.0 to meet seasonal demands and enable business growth without increasing the number of employees. In practice, this is possible through technologies such as robots, cyber-physical systems, artificial intelligence, and big data. New services. The technologies inherent in Industry 4.0 enable companies to obtain new forms of revenue, offering innovative services and providing unique experiences to their customers. In addition, interaction through digital tools allows the consumer to stay informed, creating a transparent relationship and a bond of trust with the organization. Technologies commonly used in Industry 4.0. The following are some technologies that are generally used in the Fourth Industrial Revolution. Big data. This is a methodology used to deal with data sets that arrive at an increasing amount and speed, presenting great variety and complexity. Traditional data processing software is unable to manage this information. For this reason, machine learning techniques and statistics are used to obtain important information about a business, something impossible to achieve through human action. Cloud computing. Cloud computing allows replacing physical servers and data centers with technology services that enable access to computing resources from remote devices. In this way, it is possible to save resources that would be invested in equipment, support team, and physical space and direct them to strategic actions related to the company's core business. Artificial intelligence. Artificial intelligence refers to the operation of machines that function by simulating human intelligence and behavior. This occurs through techniques that allow to interpret events, evaluate the behavior of systems, make decisions, and perform actions without human interference. Cybersecurity. Cybersecurity is a concept widely used in Industry 4.0 and refers to the protection of information assets, such as computers, against cyber threats in order to ensure the security of the information contained in connected information systems. Advanced robotics. When we talk about advanced robotics, we are referring to a concept of Industry 4.0, which is the interaction between people or environments and devices that can have their behavior changed through sensors. Internet of Things. The Internet of Things is what allows connecting equipment to the Internet using resources such as software and sensors, enabling their remote management and gaining more efficiency. Digital manufacturing. Digital manufacturing is a term that refers to organizations that optimize manufacturing operations using digital technologies. Through digital manufacturing, one can rely on an integrated computer-based system that allows real-time data analysis, impacting productivity. Additive manufacturing. It refers to the production of parts through a digital drawing in which thin layers of material are overlaid using a 3D printer. For this, materials such as sand, ceramics, plastic, metal alloys, and metal can be used. System integration. Systems integration refers to different computing systems and software applications exchanging information with each other and working in a coordinated manner, which makes it possible to analyze a business broadly and comprehensively. This technology allows obtaining information about production in real time, influencing managing and strategic decision-making. Simulation systems. It is possible to generate digital models that allow simulating real-world processes using a set of techniques associated with computers. Digitalization. Use of digital solutions in order to optimize business models, production processes, and product development. It involves aspects such as the implementation of digitalization, data collection, and approach. The three aspects affecting cybersecurity in Industry 4.0. When it comes to Industry 4.0, three aspects impact cybersecurity. They are: heterogeneous and complex park with devices of different models and manufacturers. A complex industrial park, with solutions from several suppliers, impacts the time that the technical team spends solving problems. The solution is to scale knowledge and train those responsible for the maintenance of industrial systems, recording and storing video files from the remote sessions held. Many third parties accessing the environment for maintenance, remote access control. One of the major challenges in the context of Industry 4.0 is managing third-party access to industrial park systems and technologies. This is because organizations need to grant privileges to suppliers who access the environment for maintenance using their own tools and do not always know which accesses have been granted. In this sense, one must ensure the use of a single secure means for access to systems and devices, among other measures that make it possible to provide cybersecurity to industrial systems. Traceability of accesses for maintenance of the industrial park. The lack of traceability of privileged permissions executed in the industrial environment generates insider and external threats. In the first case, employees can cause the organization to suffer losses due to accidental or intentional human errors. In the second case, suppliers may take advantage of the lack of monitoring to promote malicious actions. Other cybersecurity challenges for Industry 4.0. When it comes to cybersecurity, Industry 4.0 faces a few more challenges. Among them, we can highlight malware attacks. Many organizations use a basic antivirus and firewall, but this measure has been insufficient to prevent malware attacks, and malicious agents may take advantage of this vulnerability to invade automation systems and interfere with the production cycle. Therefore, it is advisable to adopt advanced cybersecurity measures, such as the Common Internet File System Integrity Monitoring, a system that provides an extra layer of protection and alerts about unauthorized changes to files important for industrial automation. Disabling modifications to firmware. Currently, hackers can create firmware versions and insert them into an IoT system, locking a network or generating security breaches. This has become common as an IoT network involves multiple devices with little protection. In this sense, it is recommended that IT teams examine each firmware and make sure that the drivers are updated before installing them on a network. Other recommended measures are the adoption of a permission system capable of restricting unauthorized access to the network and the deactivation of USB ports on critical systems. Bring your own device, BYOD, culture. Corporate circles encourage adherence to the bring your own device, BYOD, culture, urging employees to use their own devices in their tasks. It is believed that employees may have more comfort and produce more. In addition, the adoption of this culture makes it possible to save resources that would be invested in the purchase of laptops, mobile devices, and new terminals. While convenient, this can pose a challenge to cybersecurity if the equipment is not properly secured, as it enables hackers to hack and corrupt the entire system. Therefore, it is essential to have a firewall to be used on these devices when they are connected to an industrial network. Need to encrypt all information. A production system without real-time encryption becomes vulnerable to cyberattacks. For this reason, it is essential to encrypt all data exchanged within the IoT network to ensure its security. This is because wrong information entered by malicious users can result in reduced production and shutdown of machines. Therefore, it is necessary to adhere to intelligent technologies in terms of encryption, which can adapt to the demands of production and optimize operations. Measures that provide cybersecurity to Industry 4.0. Avoiding cyberattacks in the context of Industry 4.0 requires an approach that involves the following measures. Strategic planning. In principle, it is necessary to carry out strategic planning based on decisions about policies, strategies, and guidelines for the organization's network. Data protection. After carrying out strategic planning, it is time to shift the focus to data processing in order to provide security to critical data. Thus, it is essential to develop a security strategy that considers vulnerabilities and the future growth of the organization. Moreover, data security should be reviewed periodically, as technology constantly advances, generating increasingly sophisticated threats. Technology infrastructure design. The third measure is to design the technology and systems infrastructure, which must take its security and functionality into account. An essential part of this process is the choice of equipment supplier, and this approach allows the early identification of risks associated with the performance of third parties. Preparation of network projects with a layered approach. Finally, security architects must prepare network designs taking into account a layered approach, which allows for meeting all business criteria while maintaining cybersecurity. History of the industry. The history of the industry began in the First Industrial Revolution, which took place in England between the late 18th and early 19th centuries. In this period, the goal was to use human labor, steam power, and machines to transform raw materials into products more quickly, differently from what was previously the case with handicrafts and manufacturing. This time was also marked by the emergence of the division of labor. Firstly, the first industrial revolution impacted the textile sector, then extended to metallurgy and other industries. However, operations were only improved with the use of new technologies in the second industrial revolution, which also boosted the import and export of products. At that time, many organizations opened branches in other countries, but had to face the consequences of the two world wars. In the second industrial revolution, other energy sources such as chemistry, hydraulics, and oil began to be used. This moment also refers to the beginning of large-scale production and the adoption of production systems such as Fordism. After that, in the post-war period, there was the expansion of sectors such as automotive, chemical, and consumer goods industries and the incorporation of new technologies that characterized the third industrial revolution. Later, in the early 1990s, the Internet enabled the digitalization of industrial activities, and it was possible to strengthen international consumer relations, aiming at the fourth industrial revolution. Also called Industry 4.0, the fourth industrial revolution made it possible to automate all industrial processes with technological solutions such as artificial intelligence, big data, Internet of Things, and cloud computing, etc., allowing, among other advantages, machines to operate without human interference. Today, we already talk about the fifth industrial revolution, a concept related to the possibility of creating customized products and mass manufacturing them. This type of operation is possible by combining human capacities, such as creativity, with the work of robots, who perform manufacturing services. About Sen Hasagura? The adoption of ISA 62443 standards allows reducing vulnerabilities associated with Industry 4.0 and critical infrastructure. For this, one must adopt security policies when performing actions in industrial systems that make it possible to monitor remote access permissions to networks and industrial systems, avoiding theft of critical data and irreversible damage. The methods implemented by Sen Hasagura allow us to manage user credentials appropriately, in addition to registering and storing maintenance actions securely. Another advantage of this service is the possibility of retaining technical knowledge, which provides greater freedom in relation to suppliers. Among its benefits, the following stand out. Possibility of defining and reinforcing security policies related to authorization in industrial systems, with Sen Hasagura as the main management point of these systems. Conducting remote sessions through privileged credentials, without providing access to credential passwords to users. Implementation of the principle of least privilege, with the granting and revocation of privileges, and remote session monitoring, flagging privileged credential access policy violations. Conclusion. In this Cyber Notes Cast episode, you saw that Industry 4.0 is based on advanced digital technologies such as robotics, Internet of Things, cloud computing, and artificial intelligence. In the era of the fourth industrial revolution, it is possible to have control of all operations within a factory, optimize processes, and increase productivity. Industry 4.0 brings several benefits to organizations, and we can highlight some of them: cost reduction, increased profitability, customer satisfaction, asset monitoring, improved working conditions, provision of customized services, more agility, and new service offers. Several solutions and concepts are useful for Industry 4.0, such as big data, cloud computing, artificial intelligence, advanced robotics, Internet of Things, digital manufacturing, additive manufacturing, system integration, simulation and digitalization systems. Some of the aspects that affect cybersecurity in Industry 4.0 are heterogeneous and complex parks with devices from different suppliers, third parties accessing the environment for maintenance, and access traceability. Other factors that impact cybersecurity in the context of Industry 4.0 are malware attacks, disabling modifications to firmware, bring your own device, BYOD, culture, and the need to encrypt all information. To ensure security for Industry 4.0, it is necessary to take measures such as strategic planning, data protection, in addition to designing the technology infrastructure and preparing network projects with a layered approach. The history of industry began at the end of the 18th century, with the first industrial revolution. Today, we already discussed the fifth industrial revolution. Was our article on Industry 4.0 helpful to you? So share it with someone else who may be interested in the topic. Thank you very much for listening. I look forward to seeing you in the next Cyber Notes cast.